Hey guys, welcome back from spring break. I hope you had a good break. I'm going to be posting this a little bit before spring break is over, but hopefully you won't be watching it until Monday. So, we're just going to start with the review. We only have one section left in the chapter. So, reminder that there will be some form of assessment on the Tuesday after next, which is, I'm trying to find the date for you. Oh, I don't have the date. Let's see. It's going to be, what is it, the 28th, I believe. So not like 2 or 3 days from now, but a week after. So we're just going to do a little bit of quick review. I'm going to give you a review assignment, and then we're going to cover the new section after today. So these trig identities you need to memorize. You probably already have these memorized. You definitely already have these memorized. These ones should hopefully be pretty easy to memorize. Maybe I can take some time to show you why these ones work, to make them easier to memorize if this video doesn't get too long. And then these ones I showed you how to get. If you can memorize this one, then you can get these two by dividing. So go through those notes. Actually, pause me for a second and take out your notes. Okay, and then we started simplifying. We have the guidelines for trig identities that we're going to talk about when I go over, or when I review a problem that we went over. These were just some basic simplifying expressions. Problems, a lot of times we want to turn things into sines and cosines, but not always. This was another simplifying where we had to give them a common denominator. And this was just baby steps to get us to problems like these ones. These ones are easier because you already know the answer. This is the answer, and this is the question. So we want to get this side to equal that side. So this is an example of one where we don't want to get the left side into sines and cosines because we don't have sines and cosines in the answer that we're trying to get. If you look at this one, you can see that there's only cosines on the right side. So remember the guidelines. Start with the more complicated side. Start with the more complicated side, and we only work one side. So this side has more stuff to it than this one. So I'm going to work the left side. Most of the time the problems are set up so that the left side is the more complicated side. And then I can see I only want cosine squared, so I need to do something with that sine squared. And if you don't know the identities, this is going to feel like a foreign language. Over here, we want to get it to equal 1. Again, if you know this identity, this becomes a really easy problem. If you don't know this identity, this is straight up 1 plus tangent squared equals secant squared. It's in your notes. Then it becomes a little bit more difficult. Okay, so that was the 7-4, the beginning of 7-4. Nope, that was all of 7-4. Actually, we didn't have 7-4B notes. I just went over those homework problems on that second day of 7.4. And then 7.5, we learned some new identities. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Hopefully you remember that. And then I don't have anything for you for the tangent ones you might remember. So we do these so that we can find sines, cosines, and tangents of more than just 30, 60, and 90 degree reference angles. Technically 90 is not a reference angle, so I should say 30, 60, and 90 in all 4 quadrants. So now we can find things like sine of 195 and tangent of 15. By breaking the 195 into 45 and 150, we always want to pick angles that will work in our unit circle problems. 45 we know. 150, we have to think, okay, well, that's got a reference angle of 30. It's 30 degrees away from 180. And then you just kind of have to play around with the numbers to figure out what to break that 195 up into. Generally, the ones that end in a 5 are easy because you know it's going to be a 45 with something else. And then just applying the formula here. So sine, cosine, cosine, sine, and then evaluating those trig values and simplifying. Same thing here. We have something that ends in a 5, so I know I'm going to need a 45. 45 minus 30 is equal to 15. And then applying the tangent formula, which I don't have a song for. These ones are always a little bit more difficult because we always end up with fractions within fractions. So we have to multiply by the LCD to get rid of those fractions. And we have to rationalize the denominator. So simplifying all the way down. And then in 7.5b, we didn't know the measures of angles, so we just referred to them as alpha and beta. And we drew a picture for alpha and a picture for beta. Oh, I didn't label this. This angle, we always are talking in standard position, which means starts on the positive x-axis and rotates counterclockwise. So this gave me the 7 and the 25, and we used Pythagorean theorem to get the 24, the y over r. This x over r gave me the 4 rad 41 and the 41, and we used Pythagorean theorem to get the y value. Going down means it's negative, so don't forget that. I think I forgot that when we first did this. And then we went through and found sines and cosines. Okay, somebody asked about... Okay, I'll look at that. I just remembered what it was. Okay, so this one was just straight applying the formula and then using the pictures to find the values of all 4 of these things and simplifying. Same thing here, applying the formula and then using the picture to find all 4 of those things and simplifying. And then same thing here, applying the formula. So somebody had asked about the 5 over 4 here. And maybe I misunderstood the question, but the 5 over 4 comes from this. Tangent of beta is y over x. So y over x gives me that. And the rad 41 cancels out. Ignore this 6 over 6 for now. That was giving them a common denominator. Let me scoot that up a little bit. The rad 41 cancels out, and then the negative turns into a plus 5 over 4. So that's where that 5 over 4 came from instead of 5 over 24. So we worked this one out in 2 different ways. The first way, sorry about the shadow, there's really no way around it. Well, let me try and turn the light on real fast. That might help a little. Now we have a different shadow to contend with, but that's okay. The first way was to smush the top and smush the bottom. So I gave these guys a common denominator of 24, and I gave these guys a common denominator of 16, and then I added the 2 fractions on top, and I added or subtracted the 2 fractions on bottom, and then we multiply by the reciprocal. This is the method that generally is more difficult and longer and opens you up for more mistakes. Or going back to this fraction here, 7 over 24 plus 5 over 4, right? And then this fraction, so I went back to, oh, I think I know where the confusion was. Because of this arrow. I wasn't taking this to this. I think that's where the confusion was. I was going back up here. So the 7 over 24 plus 5 over 4 on top, and then the 1, the negative, right? 1 minus the 41, rad 41 cancels out, and this becomes 35 over 16. Okay, so going back here to get that, and then multiplying by the LCD on every single thing. So basically I'm multiplying top and bottom by 48 and distributing, and then that gets rid of my fractions right away. The 48 and the 24 cancel out, the 48 and the 4 cancel out, the 48 and the 16 cancel out, and I have much less arithmetic to do, fewer calculations to potentially make mistakes on. Okay, so that is what we've learned so far. Really quickly, I want to show you where those negative, those even odd identities come from, so that maybe they're easier to understand. So let's just call this 7.4 to 7.5 review. And it's not going to be very long. I don't want this video to get much longer. So one of the even odd identities is that. And what that's saying is I have some angle theta. I'm going to put it in the first quadrant just because it's easier to see, but it'll work in any quadrant. I have some angle theta. And I want to find a relationship between sine of theta and sine of negative theta. So if this is theta, then negative theta would be like that, right? It would be the same exact triangle. The measure is the same. So if this is 30, then this is 30. If this is 60, then this is 60. If this is 27.2, then this is 27.2. It's just the positive indicates a counterclockwise direction and the negative indicates a clockwise direction. So this, the lengths of these sides are the same. And then obviously this is the same as itself, right? They have a shared side. And then the hypotenuse length is the same as the hypotenuse length. It's the exact same triangle. So what we're saying is sine of theta is y over r. We know that, right? If I flip this triangle down, then whatever this number is, this would be the opposite, right? If this is a 4, then this is a negative 4. Oh, that scared me. Sorry, I did not turn my phone on silent, obviously. So sine of negative theta, this r is congruent. This is the same length, just the opposite sign because it's going up instead of down. So this would be negative y over r, okay? And you can see that these are opposites. Y over r, negative y over r. So if I instead multiply this side, if I multiply both sides by a negative, now I have y over r and y over r. These two things must be equal, and that's what this identity says. Okay, so let me show you with the tangent's going to be the same. It's just going to be y over x instead. And you can see that it's going to work out exactly the same because x is congruent to itself just like r was congruent to r. The cosine, this value right here, that side length is x units long. Cosine is x over r. Cosine of negative theta, so this triangle here, well, that x is the same in both of these triangles. So it is still x over r. This side length in this triangle is the same as this side length in this triangle. So those actually have the exact same value. So this is equal to this because those are equal. And that's the identity. If you look on your notes from 7.4a, that's the identity as well. So if you need help with remembering the negatives, you can draw a picture and figure out if they're opposites like the y or if they're the same like the x. Okay, so like I said, I'm gonna post a review assignment to just refresh your memory on this stuff, and then tomorrow or whenever you're doing this, the next video is gonna be 7.6a.